check a number prime or not, click on new class, write the class name. Let us class name is prime. OK. Double click here. Control A, delete key. Then this is the page. Write the comment. Here is comment to check a number prime or not. To check a number prime or not, we have to use the scanner class. For this one, we have to write import statement. Import java.util.scanner semicolon. This is import statement is used to include a package. Here java.util is the package and scanner is the class. So this statement includes a package java.util which contains a class that is scanner. Now public class. Public class name. Class name is prime. Then curly bracket start. Then public void display. Public void display is a function. This is display is a function name. Right here scanner statement, that is scanner in equal to scanner in equal to new scanner in bracket system.in. System.in. Here in is the object. Here an object is created, that is in. Scanner as capital, here system as capital, and this is scanner as capital. Now to check a number prime or not, you have to enter a number. For this one, first write declaration part. The declaration part is int n. Then write system.out.println as capital system.out.println. Enter a number. Enter a number. To input a number, the statement is n is the variable, n equal to in dot next int I capital. This statement input a number. To input a number and receive the number, you have to write next int to receive an integer number. Now to check a number, it is prime or not, you have to check it has only two factor or not. If a number has only two factors, then it is a prime number. The two factors are 1 and itself. To check a number prime or not, we have to write for loop for I equal to 1, I less than equal to n, I plus where I is, we have to declare the I, so comma I, then semicolon. For I equal to 1, I less than equal to n, I plus. We have to check this one. This number is divisible by 1 and itself or any other numbers are there. You see, for I equal to 1, I less than equal to n I plus plus. If I modulus, if n modulus n modulus I equal to 0 or equal to 0, we have to write double equal. If n modulus I equal to 0, means n is the number, I is the 1 to this number. First time I value of I is 1, n is divided by 1. If this is divisible, n modulus I equal to 0 means remainder is 0. N is divided by I, and this is divisible means remainder 0 means this divisible. Then you have to give a counter, that is k plus plus k. You have to declare here k as value of k is 0. K is to find the number of factor. If n modulus I equal to 0, this statement is to find the factor is divisible, n is divisible by I or not, and k plus plus is the counter. This is the counter for number of factor. This is the counter. So this means first time value of I is 1, that n is 5. Then 5 modulus 1 equal to 0. Yes, 5 is divisible by 1, remainder is 0. Then value of k will be 1. Then value of I is 2. N is 5. Let n is 5. Then 5 modulus 2. 5 is divided by 2. Is 5 divided by 2? Is remainder 0? No. So k will be 1 only. It will not be increased. The value of k will be 1. Then value of I is 3 and n is 5. 5 modulus 3 equal to 0? No, 5 is not divisible by 3. So k is 1. So like that, 4 value of I, 4 is not divisible, so k is 1. Then value of I is 5. 5 is divisible by 5, so value of k is 2. So there are number of factor is 2. So let n is, if your n is 8, if n is 8, I equal to, first value of I is 1, then n modulus I. What will be n modulus I? N modulus I means 8 divided by 1. 8 divided by 1. 1, 8, 8, so remainder 0. This is n modulus I means this is remainder part, that is 0. So it is divisible by 1. N modulus I equal to 0. Now n modulus I equal to 0, so k equal to 0, initial value of k is 0, now k plus plus, so k value is 1. Now n is your 8, I is 2. I equal to 2, n modulus I means 8 is divided by 2. 8 is divided by 2, 2 4 ja 8, this is 0 remainder. So k value will be increased, that is 2 plus 1 2. Now value of I is 3, n is 8, value of I is 3, n modulus I. N modulus I means 8 is divided by 3. 8 is divided by 3. 8 divided by 3. How much? When you divide 8 by 3, 3 2 ja 6. 8 minus 6 is 2. So remainder is 2. It is not 0. So n modulus I equal to how much? 2. It is not 0. So this is false. This condition is false. So k will be 2 only. It will not be increased. Then value of I is 4. 4 is divisible by 8. So this is remainder is 0. So k will be increased. That is 3. Then 5. Value of I is 5. Value of I 5. And it is not divisible by 8. So 8 divided by 5. equal to how much? 5, 1 is 5, 8 minus 5 is 3. Remainder is 3. It is not true. If this condition is true, then only k will increase it. So k will remain constant, that is 3. Then value of I is 6. 6 is not divisible by 8, so this is also k will 3 only. 7 it is not divisible by 8, so k is 3. 8 it is divisible by 8, so k will increase, that is 4. So last value of the k is 4. So number of factor equals to 4. K plus plus at last, what will be the value of k? K will be 4, that is number of factors. So n divided by I of from 1 to n, the factor are, number of factor are 4. What are factors? This is 1, I divided by 1, 2, then 4, then 8. These are factors, 4 factors. Now, if the number of factor is 2, then it is a prime number. So, right here, if a equal to 2, a double equal to, then it is a prime number. Write system dot out dot println prime number. Else not prime number. Else system dot out dot println not prime number. Let us check the output. To check the output, let us compile it. How can you compile? See, this is compile. No syntax error. Now close this one. Right click here. New prime. Okay. Right click here. Word display. Enter a number. Let the number is 17. Enter prime number. Let us do again. Clear option, clear. Then again enter number. Let this is 18. Enter not prime. It is not prime. Okay.